Hey everyone, sorry. Okay, what's up with my camera? Sorry about that. Not sure what happened. My computer basically froze. Give me a second to fix the camera. Looks like it just needs to be reconfigured. Yeah, the exposure got set way down low. Way down low. There we go. Okay. Come on, Steam. Get out of the way if you're not going to do stuff. Alright, so yeah. Computer crashed. Froze up. All sorts of good stuff. So hopefully things didn't get too... Oh yeah, that's right. I started work on a object reader in Writer. And if only we had verts to output. All sorts of stuff here. Z object. Wait, what? Why did you open that? What the And this is why you back things up with a good little system. Yeah, I just opened this up directly and it's all nulled. So, because my system froze in the middle of trying to write the file, it got corrupted. So, this is why you use a versioning software. I will now revert the script. And there we go. It's back to normal. Well, back to where it was, I should say. Alright, so back to where we were going. Let's see. Where were we? We were... Alright, so we were in the middle of doing something very interesting. I forget what, but it was interesting. Yeah, a lot of stuff there. Alright, no, we want the original Blender script, because that tells us more. Okay, so let's put this down here for a moment as we come through and try to figure out... Alright, oh, all the bone readings! Yeah, vertex readings. Read additional. Yes, I know there's a new version of Java. You don't have to tell me. File data clear. Alright, so Z-object read file. The file, read, resize, close. What's the file? It's an IF stream. So, read file data. Okay. Locate rig. If not, get rigs. So now we're at get rigs. So, now we know the rig offset. So, let's start by doing a seek. Or no, wait. How do we do this? Ah, mean copy. I love this music. Okay, so first thing we want to do is we want to make sure that our offset, J, is within the size of our data. And actually, the more I think about it, I think we need to have the data available here in the Z object. I think we're doing this as a string. Yeah, string file data. Byte array. I guess we gotta do standard. We might be able to get away with Q string, but I don't know about that. So, all right. File data, resize the file, read. Okay. So there. So now, file data equals file data. Okay, so now our global file data is now accessible. So if rig size, okay. And let's copy paste. So if rig offset equals 0, if file data size equals 0, return false. And now, if J is greater than file data size, continue. So any rig that's bigger, that's, you know, larger than the length of our file, our string basically, gets automatically, you know, that got moved, gets automatically shifted over, or rather it says, yeah, we're gonna skip this one. Now this shouldn't do too much, but you know, you never know sometimes. All right, we were successful. Good. All right. Zelda64 reader. Okay, so right now it is not getting down here probably because it says file data 0. Now what we could probably do is mem copy destination file data source file data size of file data size. I'm only guessing at that. So, let's see if that worked. Nope, it crashed. Alright, so okay, so that didn't work. Yeah, how does that always get? Size equals file data size file data file data append. Actually, yeah, let's just do file data append, and we'll add file data to it. That might work. Or it might not. I don't know. Nope. Insert. File data equals I don't know, maybe that'll work. Shouldn't. Ah. Alright, so now we got get rigs, constant standard string at file data now we'll come up here, constant string file data alright, so now this should work. No. Okay, so if j is greater than that, so the rig offset integer I. Oh, let's do this before it gets twisted. Okay. So does that mean we could actually revert this back to what we were doing earlier? Okay, so let's try this. Oh. I almost had it. Okay, awesome. We now have a global for our final. So, actually, let's, bring this up here. Okay, so there we go. If the file size that we read was 0, then we could not read the file, the data. Oh, I forgot that. Silly me. And I just realized I was in the way. I'm sorry. I don't really pay attention to things sometimes, especially when I really get into it. Okay, we are still getting the rig offset, so that's awesome. Which means we can delete a lot of this stuff. And now that we're doing that, we could actually probably remove locate rigs. Well, the inset from that. And go const. Actually, we could just do there we go. There we go. This is what it's like to use an object. Pardon me. Okay. Okay, so int jx equals j. So we're going to leave j as our actual offset, while jx becomes our hexadecimal offset. Still not sure why we need this for the offset, but that's how it's done. Oh, sorry, I'm really tired. My sleep schedule's been off lately. It's usually I get up and around like 10 or 11. Lately I've been getting up at 9. And it's one of those things where once I get up, I'm pretty much up. Alright, so that's tile. That's definitely something we need to deal with, but nowhere near now. Have we even touched on read vertex? I don't think we have. Oh yeah, here we are. I forget, does this crash it or something? Or was it just, deal with it later? Or is it proto code? Ah, cast card to int. Wait, these are supposed to be floats? Lord Frieza. The fuck? At any rate, we're at a point where we need to learn how to read the bones. Okay. In case you need to read it. Okay, so I think that's probably the problem. There we go. Alright, so we now know where the offset is for the rigs. Move it, you behemoth! Of a chair. So I'm pretty certain that... Alright, so the offset should be this plus that. But to me that just says 0. And that also says 0. Alright, so get rigs. Now, I probably could just load this up in here, but I kind of like having it in 2 different windows. Alright, so we've already read the hierarchy. Create and knit limbs, which means we need to do the limb class. Now, as you can see here, there's a whole bunch of stuff. And now I think I understand why I stopped programming this for a while. But, you know, we're slowly, working our way through this, so. Okay, so. I don't understand why it's, first you mask, the offset by everything, basically zeroing it out. And then you add 0 times bone counts. So offset will always be 0. Now, this is for each rig. Okay, there. That will actually let us know exactly what the offset is in bytes. So 6896. Okay, so if we load up the Deku Princess and we go 6986 bytes into it, alright, so Again, we are looking for 68960. 98621 930. So we are almost there. 960. Here we are. Okay, so now that I have that, and I'll keep that on the other screen so it doesn't bother you guys too much while we're doing this, let's take a quick look. Actually, I'll move this all over here so you can see it. Okay, so first, right here is 98690. So, looks like, according to this, we want to read... What's little h? I don't know what little h is. A float? Well, you know, we do have actually written data up here. Yeah, it looks like a float of 4. So, lowercase h is a float. Yeah, UVs and unpack, so it wants a float. Well, let's start right here. That is negative. That's pretty... Alright. What about this? Okay, are we reading this in the right... Oh, no. Big Indian. That's still not right. Valid offset plus 16. So this plus 16 makes it 76. So right here. So that's 4. That's still not right. Let's switch this over. Nope. What about here? Nope. Here? No. Okay, that looks like a better number. That is broken. And that's broken. If not valid offset, segment offset plus 16. Return. I don't know, are they somehow getting a float out of 2? No, that's all wrong. Okay, so Python unpack from come on. Oh, maybe this is what I want. Well, it says Big Indian. Big Indian. And little h, short. Integer, byte size 2. Okay, so self position x equals 150. 265 or 620. And let's see, h is short, so that's actually negative 25. And then that goes into a position vector. Okay. Odd. And then you divide by 48. And then we do another. You use those two and you somehow get a float? How do you get a float out of that? This makes even less sense. Oh. Oh, I'm looking at the wrong things. I was looking at other stuff. Okay. So. No, they don't. Here they just want to go straight to there. Right there. Okay, position X is still the same. So, there, there, and there. Okay, followed by child, a byte, 0. Sibling, 0. Near is a unsigned long. So near is right there. That's pretty damn big. And far is 0. I hope I'm getting this right. And then pose location. X, Z, Y. I hope that's right. All right. How does this know how many limbs? Limb count. Here we are. Segment, seg plus, offset plus 8. So this is actually where we are. We're up in here. We haven't even gotten to creating limbs. So, okay. So now we're at a little better spot here. So, where are we? Get rigs. Alright, so we have our offset, which is J. Then it's supposed to be an offset split, or split offset. Of course, here we just, split offset, and then in off, and then these two just... Oh, yeah. Okay. Let's do a split offset then. So we want integer. Seg offset. Split offset. And we want to take J, then seg, and offset. Okay, so now we have this. So lim index offset integer. I'm doing int just because it's easier. Equals unpack from course, for us, we want to do a mem copy. Unpack data. Data J. Let's do an unsigned. Unsigned int. Mem copy at here. So file data. Size of limdex. You know, I'm starting to wonder if it's not a better idea just to do, direct file reading. Kind of like what we do in the World of Warcraft thing. Let me bring that up real quick, just so you can get an idea side by side. Because basically right now, the way we're doing it is we're reading it into memory, then we're working with it. Now, what we might actually want to do, if I load up the WMO file, right now we're just reading it all from a memory. While in here, we basically go through and say, okay, we're looking for this chunk, and then we actually read the data. If we actually go, fread, we go to the root file, and if we need to, we can do a seek. That's a lot easier in a lot of ways. Here, read from mult file. Go to definition. Here it is. It's reading the data directly out of this. I mean, first it reads the data, then we process the data. I mean, that would actually make a lot of our job easier. Being able to just read it all at once, directly from the file. Might take a little longer in some instances, but at least we don't have to do any of this crap with trying to read from a memory file, which can, cause all sorts of issues. Right now, we're having the issue of, okay, how do we get the mem copy? I mean, we got to, do whiles and fors and if offsets of all sorts and kinds. So being able to read, if we could, if we had this, as a just, straight up read function, we'd open up the file, we'd send it to locate rigs. Locate rigs would go, oh yeah, I have an offset for that. Let me just seek the offset. And see here, we have, offset. We have it set to 0. Copy offset from data I, which we know where data I is. Well, mostly. So we can just copy that data and read it directly out, and then, okay, well, I know where that is, so let me check and see if that's all good. Yeah, that's good. We found a hierarchy. So, the downside is, reading multiple datas. We'd have to read the data plus 3, and then read the data plus 4, and make sure that all 3 of those are viable before being able to move on to all the stuff in here. So, reading directly would be easier in so many ways, but it also makes certain things about our job so much harder. On the flip side, we could do this a lot easier using objects. Well, class objects and such. So, yeah, I'm not sure entirely how we want to go about doing that. But definitely, just reading, chunk data directly would save so much time and frustration. Because right now I have memory copy, but I don't know where we're doing that from. So we'd have to somehow get to a certain spot in the read. Oh, I think I know exactly why I stopped programming this a while back. Okay. So, do we do that? We know certain things about the system. Hey, thanks for following me. We know certain setups about this, but we don't know all of them. I mean, if we actually, where is it? Here we go. If we come in here and look, limb, that's a very simple one. We just have that, and that we read that data, then we convert it into what we have now. But on the other hand, this is just, unpacking from the memory. So, trying to figure out that in C++, not exactly easy. We had some help. I forget. Somebody fantastic actually, helped us out with this. I honestly cannot remember his name at the moment, but if I reviewed the script, I would definitely know who it was. And I really have to thank him because it did kind of open things up for us a bit. Now comes the hard part of trying to make it work. Actually, right here. That's a pretty nice little nifty piece of code. If we started that out there. Yeah, that might work. Actually, we just put offset. Alright, so. Alright, so where did you read the limb offset? Okay, so offset. Okay, so limb offset equals data, or file data, offset. So at least we know where the offset is. So let's, even though this is, replacing, number of bones, let's at least see what kind of data we get. 6. Okay. So now we now know the index offset is 6. So if we plug that into our data here, is valid offset segment 6. Now I gotta take a quick look and see what valid offset. Alright, so if offset is greater than or equal to segment, okay. Alright, don't have to worry about that then. Except, yeah, that is... Do we have that in here? I honestly don't know. No, we don't. No, we don't. Snoochie boochies. Okay, so... offset plus integer plus count. Where did count come from? Wait. Where are we? Oh, we're in display lists. No wonder things were looking weird. Hierarchy. Here we are. If valid offset. Okay, well, I know for an instance that is a valid offset. So we might come back to that later. So you want to split that again. Right. Alright, so limb count. Here we are. Unsigned int lim count equals da, da, da. Actually, the lim index offset should not be 6. It should be greater than 6. But how do I get it greater than 6? Okay, j equals the offset. Offset equals byte swipe long offset. Offset equals 0. So read offset. So first things first. So if I just did a byte swap on this, that's a much bigger number. But that is definitely an offset that's not valid. Alright, that's peak definition. U short. There we go. That should give us a better answer. Okay, so that is a short is the index offset. Let's copy that, paste it there, and set that to lim index offset. And now lim count will actually be lim count, hopefully. Nope. Because that looks like a few too many bones. Negative 25 bones. That's not right either. Alright, so let's come back to here. Okay, there's that. There's that. Lim count equals segment seg offset plus 4. So file data. Oh, J. Discount? D-list count. So, D-list count. I have no idea what D-list count is, but we will proudly show that too. Found 25 bones. I'm good with that. D-list count of 24. So, now my question, what the hell is a D-list? And now we can actually read the limbs. Ooh, limb offset. But at least we actually got it to read the number of bones, and, well, I'm just happy with that. Screw the rest of it. We're done for the night. No, okay. I'm still not sure what D-list count is. Okay, not seeing it up here. I'm not seeing it anywhere. Yeah, I have no clue where that is. So, let's do a search. Alright, there's that. Find neck. Yeah, there is no uses for this other than just having it. So I don't need that information. So, we found our number of bones. That's awesome. For size T, B equals 0. B is greater than or less than limb count B++. I should probably make this size T. At the very least, it increases the memory usage. Okay. So, U long. Limb offset equals by U short long. U long. File data offset plus 4 times I. Plus 4 times, well, in this case, B. Limb rig offset. All right, there we go. Oh. Well, unsigned long. Maybe if I didn't do that. No, it definitely has to be byte swapped. Okay, that's just not giving me the right offsets. Let's take another look at this. Offset doesn't change since we split it. Oh. No, offset, that's right. Let's do an unsigned int. I guess not. Well, you know, maybe we do need to change this up. I mean, as far as I know, we're never going to need negatives for an unsigned offset. And it could be very well that that's what the problem is that... No, it's not. But still, that was probably a good change to make anyways. Okay, so this will at least let us know what the offset is. Huh. I don't think it's offset plus 4 times B. That'd be nice, but... Alright, so... Alright, so... lim offset, unpack from greater than L, which means long, sign long, segment, offset plus 4 times I. Okay. It's unsigned long. Big Indian. That's what this is telling me right here. Big Indian. Big Indian. All right, well, let's try that. Let him off. All right, so limb index offset equals limb seg and limb off. And B is supposed to be... Oh, okay, I was supposed to use that. Okay. So that's probably where the problem came in. I hope. Nope. Limb index offset. Don't care. Yeah, the split doesn't really help us. Okay, so there's that. Rig offset. If I turn that off. We're still having the problem. It's just at a different spot. Okay. We're following the directions. Limb offset equals unpack, so byte swap U long. Yep, unsigned long. Index offset plus 4 plus our loop, which is B. I is actually, offsetting for each rig we find. Although, in theory, we should only have one. Ever. offset plus 12 is valid. So, what we just did plus 12. Nope, it just adds 12. Wait a second. Limb offset plus 12. So what is this? Limb offset. Unpack, limb index. So this is telling, it should be telling us where the offset is here. But if we come up here to, let's see, let's look at 1536. 36. Those are two possible values. Oddly enough, that's not what we're getting. Even accounting for the... yeah, here, this should be negative 11, so... Even if we account for the using direct, formats... Yeah, data at 1536. Should be that. Oh, it could be that this isn't reading enough data. Yeah. Notice here that you're doing a mem copy, then you're reading the data. Okay. Mem copy. And limb offset source equals file data. Oh, even better. At file data. Offset, I believe. Size of unsigned long. And then unpack data. So in this case, limb offset equals byte swap limb offset. Okay. Okay, that looks like the data we're getting. Yeah, that's much better. So, only down here am I seeing 2 valid offsets. Well, 3 if you count that one. But I don't think that's a valid offset. So, if we were to trust this particular offset, let's see, where is it? There we are. That is the byte we are trying to read. And now we are actually getting the proper numbers. Problem is, I'm not sure that's the right offset up here. So our off, I think, might be off. Lim offset. Let's do the same thing here. Do a mem copy at lim index offset from file data. Oh wait, this is in memory, so there we go. Size of short. Oh, unsigned. Short. Okay, so there we go. Maybe that'll give us a better data. Well, that is a bit different. But that's still invalid data. What happens if we don't byte swap it? Much lower and much worse. Found 25 bones. Morning, pink hair. Still giving us wrong information. Oh. All right, let's double check this. Oh no, this is a long. Okay. Yeah, the index offset is an unsigned long. So that could be why we weren't getting the data we needed. What? Out of range? Alright, limb index offset. If nothing else, this gives us another step forward to learning what's going on. Okay. So this index is actually wrong. Okay, so let's try this again. It was J, I believe. Oh well. A rebuild's just as good as a build. Okay, that's still freaking wrong. And offset 0 now. Yay. Okay, that takes us back to numbers that, work, even though they're wrong. Because look, this is, greater than and big L. Big L stands for an unsigned long. So, if we come back here, set that to an unsigned long, that to unsigned long, and shift this back to unsigned long. Now, you'll notice we're not reading any data before here. Right now we're just reading stuff from memory. Here is where we do our first read from data. And we do that from offset. Offset is copied basically from J. In fact, let's see, limb offset. J offset. So now I can do this, J offset And now we'll see exactly what the those numbers are. Now, as you can see, both the J and the offset are identical, even though we've gone through this split offset. So basically, split offset does nothing for us because, you know, that's like part of the old system. And the old system has to do with, you know, having multiple, you know, things all at once. Did I now put a chat box in here? Well, no, I did put a chat box in here, but for some reason, it's not linking up. That's weird. All right. Okay, so we know that number. So let's come down here to 6, 8, 9, 60. Yeah. Now see, that looks like a proper number, but that's plus 3 from where we're starting. Now, did I miss something here? Offset, 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 plus 9. If not valid, offset, segment, segment plus 9. Return. On the other hand, there's 25, but that seems to be this number, plus 4. Limb count equals offset plus 4. Limb index count from the segment and the offset. So it should be this. Actually, it should be that. And here it's just checking for offset plus 9. 8, 9. Still not sure what D-list is about. Rig offset equals J. So J is our offset. And as we mentioned before, split offset does nothing. So that's nothing we have to worry about. So our offset is the the wonderful 8960. So if we start there and read data, we get that 10. Let's see, yeah, 10,700,000. All that. And that's reading from a large, unsigned long character. Which, as we come here, we can see is accurate. Unless we're only reading that. No. So, limb index offset plus 4 times I. Yeah, this is making no sense. All right. What the heck is this? I've gone through this twice now. This is just checking for validity. It doesn't have anything, it doesn't change any data. Yeah. Just as long as the offset, the second number, is greater than the length of the segment, it should be fine. So it's just checking that, you know, our offset plus 9 is still valid. So here's our offset, plus 9, definitely valid. Limb index segment. I don't know, maybe we need to do this. Don't think it will. We've tried this several times, but... No. Okay, there we go. Okay, that actually is different. course, now this data is still off. But we're very slowly making our way through this. Limb offset equals unpack, byte swap, long, yep. Huh. Look at this. The data is actually pretty consistent. It's like I just need to subtract those first numbers. I don't know. It's, you know, it's definitely not an offset. At least it shouldn't be. But okay, oh, so very tired. Yeah, I'm going to call it here for tonight. We definitely got farther, which is a good thing. We actually got it to read the total number of bones, and we've got it so it's actually reading the bone data. Yeah, it's not quite getting that right, but we're getting closer. Yeah, not much more to say. We didn't get nearly as far as I wanted to get, but we did have a computer freeze up. Only happens once or twice, ever, on this chip. And it's not overclocked, so, yeah. Of course. If I hooked this in, it probably would never overheat again, so. Now, as much as I would love to install that on this system, I only have to wait maybe a week, and I'll have my new motherboard chip and RAM, and I can just drop all that right in. And I'll definitely be putting that on there. So, there's all that. I do look forward to having that all, nice and fast and spiffy. I just hope my power supply holds out on it. I don't think it's going to overload it. I'm just concerned that it's like a 7, maybe 8-year-old power supply. As far as I can tell, it's still going strong. I'm just concerned that the connections won't be up to par. It's a concern. All right, so with luck, I will have my lights all set up and be used for tomorrow's stream. Hopefully everything will look really pretty. I think I will go and play a game with that when we actually do that. Not sure what. I like Dota, but I'm kind of getting burnt out on it, so I'll probably shift over to something else. We do need to finish Chrono Trigger. I'm just like, not quite. Because that's a game where we actually need to do a ton of leveling up first. But at least we've got at least one big zone to do, which is Ozzy's fortress. The other thing we can do is start Batman Arkham Asylum. I've been wanting to do that for a little bit. Now, I can also show you what's Long Live the Queen's like, because that's actually pretty fun. So, all right. As always, you can donate here. You can donate up here. You can watch me live on over here. Follow me on Twitter. I usually tell you what we're going to do, and when about 20 minutes or so ahead of time. I got to get better at telling you like an hour ahead, but I'll get used to that. All right. Anything else? Oh yes, people on YouTube, please like and subscribe. You liking and subscribing lets me know what you like, if you like, all that good stuff. Also, when we get like a ton of viewers, YouTube will actually send me a plaque. I'm kind of looking forward to that. I know it's a long ways away, but, Also, if you enjoyed this, tell your friends. I would love to get more people to come in, more people to talk and everything. I'm not sure what happened with chat today. Nobody was able to chat, so I will... well, you're able to chat, but you're not able to chat with me on the stream. I'll look into that. It could be that I ran too many copies of the same program, closed them all, and, one of them didn't connect. So, alright. Thanks for joining me, and I will see you tomorrow at 10 p.m. Pacific time. Bye!